welcome to Supergrad's YT channel. Today I'll be telling you how to solve linear equations. My name is Abhishek Pandey and I've been teaching students for last 10 years for CAT and other management entrance exams. To learn this, first of all, we need to understand what are linear equations. So linear is derived from the term line, that is a straight line. So any equation, if plotted on a graph, would yield a straight line that will be a linear equation. For example, 2x plus 3y is equal to 6. This is a linear equation. Plotted on a curve, on a graph, this will look something like this, with this will be 3 comma 0, and this is 0 comma 2. So as you can see, this is y-axis, this is x-axis. If I put 3 in place of x and 0 in place of y, I'll get 2 3 is 6. And similarly, if I put 0 in place of x and 2 in place of y, I'll get 6 again. So they're just a representation of a straight line in form of an equation. Now, in this class, which is basically a foundation class, we'll learn how to solve the equations. Basically, when I say solving an equation or getting to a solution, so a solution essentially means the intersection of two straight lines. So let's say this is one line, another line is this one. This is the point which is actually the solution set. So a point which satisfies both the given equations, or geometrically the point which is the intersection of both the straight lines, that will be the solution. Now coming to the main agenda, that how to solve a linear equation. By the way, a linear equation would be having x, y, and their coefficients, let's say a, b, and then a constant term. So ax plus by plus c is equal to 0 is the general form of any linear equation, where a is known as the coefficient of x, b is known as the coefficient of y, and c is the constant term. By coefficient, I mean to say that is the frequency of x. So instead of writing x plus x, we write 2x, where 2 becomes the coefficient. It's as simple as that. So whenever we need to find the point of intersection of two straight lines, we require two equations, right? So let the first equation be a1x plus b1y plus c1 equal to 0, and the second equation be a2x plus b2y plus c2 is equal to 0. We need to solve for these two system of equations. I'll call it system of equations. Cool. Now, there are multiple things which can happen. So let us talk about the first case. Case 1. In case 1, what happens? A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. So as you can see that all the coefficients and the constant terms are proportional. The ratio is same. So in this case, what actually happens? What actually happens, that is what we'll discuss in the first case. By the way, in this, we will be getting infinite solutions. I'll tell you how by giving some examples. Infinite solutions. This is going to be the first case, infinite solutions. So let me take an example. For example, if I take 2x plus 3y is equal to 6. By the way, I can send the constant term on the right hand side. That is possible. And whenever we send something from left to right, the sign reverses. So here, if it is plus, it becomes minus on the right hand side. That is something which we all understand. If it is multiplying in the left hand side, in the right, it will be dividing. So the reverse of addition is subtraction. The inverse of multiplication is division. That is something which we must keep in mind. So the first case, 2x plus 3y equal to 6. And another equation is 4x plus 6y is equal to 12. Now, if you see this, so here we'll be discussing the first case as well as the method to solve the equation. So what we need to do, if somehow the coefficients become same, we'll be able to cancel it out. Let's do that. If I multiply the first equation by 2, it becomes 4x plus 6y equal to 12. So both the equations will be same. And if I subtract, all I'll be getting is 0, because everything will get cancelled in the left hand side. And same, 6 into 12 minus 12 is 0. So 0 is equal to 0. Wow. So what actually happened over here? Both these equations are essentially representing the same straight line, or we can say graphically both the lines will be overlapping with each other. So when I said the solution is basically the point of intersection, so when two lines are overlapping one over the other, then all the points in that line are intersecting. So we have infinite points of intersection, and that is why I told you that we'll be getting infinite solutions. Great. And as you can see, 0 equal to 0, that is mathematically correct. So we will call this case a consistent case. This case is consistent. So we have discussed the first case altogether. Now coming to the case number 2. So in the case number 2, A1 upon A2 is equal to B1 upon B2 is not equal to C1 upon C2. What will happen now? I'll give you an example. 2x plus 3y is equal to 6. 4x plus 6y is equal to 9. As you can see, 2 by 4, 3 by 6, it's proportional, but 6 by 9 is not proportional. So in this case, what you will get no solution at all. No solution at all. What does that mean? Okay, let us try to solve it first of all. If I multiply the first equation by 2, this becomes 4x, this becomes 6x, this becomes 12. And if I subtract second from it, 4x minus 4x is 0. I'll get 0 on the left hand side, but on the right hand side, I'll get 12 minus 9 is 3. 0 is 0 equal to 3? Not really. Mathematically, 0 cannot be equal to 3. It is not equal to 3. So this means that this system is inconsistent. Now you must remember the first case was consistent, second case is inconsistent because mathematically 0 is not equal to 3 and we get no solution. What does that mean? Graphically, what does that mean? Two lines have got no solution. That means they are not intersecting at all, which essentially means that the lines will be parallel to each other. Great. So in the first case, lines were overlapping. So there are various ways to look at it. The first way, system is consistent or inconsistent. Then algebraically, we talk about the cases, case 1 and case 2. And then graphically, in the first case, lines were overlapping. Second case, lines are parallel. Now comes the case 3, in which we'll actually be able to find one unique solution. And that is the case which we are looking for. In that, A1 upon A2 is not equal to B1 upon B2, and this case is independent of the constant term, that is independent of C1 and C2. For example, 2x plus 3y is equal to 6 and 3x plus 4y is equal to, let's say, 8. So as you can see, 2 by 3 is not equal to 3 by 4. This can be solved. To solve this, what can be done? If I want to eliminate, let's say, y, so I'll multiply the first equation with the coefficient of y in the second equation, that is 4. And I'll multiply the second equation with coefficient of y in the first, that is 3. Once I do that, what do I get? This 4 into 2 becomes 8x, 4 into 3 becomes 12y, 4 into 6 becomes 24. Here 3 into 3 becomes 9x, 3 into 4 becomes 12y, 3 into 8 becomes 24. Now, as you can see, what is happening? If I subtract, this gets cancelled, and 8x minus 9x, that is minus x equal to 0. That means x equal to 0, of course. So we got the value of x equal to 0 in this case. Great. Now, once we got x equal to 0, how to find y? To find y, we'll use the method of substitution. So y can be rewritten as from the first equation, y can be written as 6 minus 2x. So 2x goes this side, on right hand side becomes negative, divided by this 3. So 2x is 0 already, we can put it there. So y will be equal to 6 minus 2 into 0, that is 0 only, upon 3. So y becomes 6 by 3, or we can say 2. So y is equal to 2 and x equal to 0 in this case. So we have got 3 different cases. In the first case, the lines were overlapping, there were infinite solutions. The second case, lines are parallel, there was no solution. The third case, lines are intersecting. The lines are intersecting, and we got one unique solution. And moreover, because we are able to find a solution, this system is also consistent. So you got to know that two systems are consistent. That is the first case and third case. Second was inconsistent because we got no solution. This is all about the beginning, the foundation of linear equations. We'll meet in more such sessions. Stay tuned. Thank you.